Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this video, I will be solving another set 2 of multiple choice questions. These questions are from the MCQs in Mathematics supplementary book by author R.T. Sharma. I will be solving some selected conceptual problems. So this video is based on the chapter of coordinate geometry, and it is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, the first question says the abscissa of a point is positive in the. Now, we know that in the Cartesian plane, sorry about my drawing, it is very approximate. So, we have origin O and the y-axis and the x-axis, they are mutually perpendicular to each other and they are intersecting at the point at the origin O, whose coordinate is 0, 0. Now, the abscissa of any coordinate of any point, the abscissa is always positive towards the right hand side of the y-axis. So, in this direction, the values of x or x coordinate or abscissa are positive, and in this direction, the value of abscissa or x coordinate of any point is negative. Similarly, for the ordinate of in this direction, the ordinate of all points is positive, and in this direction the ordinate of all points are ordinate of all points are negative. Okay, so now we know this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So in which quadrants the abscissa or x coordinate of any point will be positive? Clearly it will be first and fourth, because the points, all the points on the right hand side of the y-axis have x coordinate positive, that is, or it is the positive direction of the x-axis. So any point lying on the positive direction of the x-axis will have positive abscissa or x coordinate, and those and the quadrant 1, first quadrant and the fourth quadrant are the only two quadrants which lies in the positive direction of the x-axis. So the correct choice will be D, fourth and first quadrant. Let's see the next problem. Two points having same abscissa but different ordinates lie on. Now, if you have same abscissa, so I am roughly drawing the so any point, so 2 points having the same abscissa, meaning those 2 points. Now, what is the abscissa of a point? Abscissa of a point is nothing but the distance from the y-axis. If the abscissa or the x coordinate is positive, it means it is at a positive distance from the y-axis, that is, it is towards the right hand side of the y-axis, and if it is negative, then it is to the left hand side of the y-axis. So if two points are at the same distance from the y-axis, it means that the line joining those 2 points has to be parallel to the y-axis. It is x coordinates are same. Okay, x coordinates are same. So obviously any 2 points having the same x coordinate will be of the form. Let's say I am considering any point P. Let's say its coordinates are alpha, beta. So abscissa is alpha and ordinate is beta. Now if I consider any other point having the same abscissa alpha, then it has to be at that point has to be at the same distance of alpha to that, since the point P is to the right hand side of y, that the other point Q will also be to the right hand side of the so since the other point Q will also have abscissa alpha, which means that it will be at the same distance from the y-axis and on the right hand side. So this will be alpha, comma, ordinate could be any other thing. The ordinate could be some any other ordinate other than beta, let's say beta dash. So clearly, if I join the points P and Q, this will be parallel to the y-axis. So any two points having the same abscissa or x coordinates, the line joining those 2 points are always parallel to the y-axis. So the correct choice is D. Let's see question number 3. The perpendicular distance of the point P of the point 4, 3 from y-axis is. Now let's say, what is the perpendicular distance given a point? What will be the perpendicular distance of the point from the x-axis and the y-axis? This concept has to be very clear. So this is the Cartesian coordinate axis, y, y dash, x. Let's say we have a point over here. Now whenever I will consider a general point, I am always considering the point to be in the first quadrant. That need not be the case. The point could be anywhere in any quadrant. Let's say this is alpha comma beta. Now since I am drawing the point P in the first quadrant, obviously alpha will be positive and beta will be positive, but this point P could be anywhere. It could be in any quadrant. So this is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. Okay. So now given the coordinate of a point P, what will be the perpendicular distance of the point from the y-axis and x-axis? This concept need to be you must understand this clearly. Now obviously the way we define a coordinate of a point, the abscissa or the x coordinate is always the distance from the y-axis. Now if the x coordinate now please mind one thing, that the distance in the Cartesian plane, distance is always a positive value. Distance is never negative. The abscissa or the x coordinate can be positive or negative, but the distance, the perpendicular distance of this point, of any point from the y-axis and x-axis, is always a positive value. It is never negative. So for any point P where the coordinates is alpha comma beta, we don't know. Even though I have drawn the point P in the first quadrant, it could be anywhere. So the distance of any point from the y-axis is always the abscissa or the x coordinate, but it will be modulus of the abscissa. So perpendicular distance of P from y-axis, this is the basic concept. Perpendicular distance of P from y-axis is equal to modulus of abscissa, the value of abscissa, which in this case modulus of alpha, where I have considered the coordinates of the point P to be alpha comma beta. This is the perpendicular distance of the point P from y-axis, that is modulus of abscissa. What is modulus? Modulus means the numerical value of abscissa or the absolute value of abscissa. This is the mod operator to denote the numerical or absolute value of any number. Similarly, the perpendicular distance of this point from the x-axis will be modulus of ordinate. So I have to make out some space. Okay. Similarly, the perpendicular distance of the point P from x-axis is modulus of ordinate or y coordinate, which in this case is modulus of beta. This concept you must know very clearly. So it is always modulus. Now if suppose if there is a point over here, let's say Q, whose coordinates is, let's say, minus 6 comma 2, what will be the perpendicular distance of this point Q from the y-axis? It will not be minus 6. It will not be minus 6. It will be modulus of minus 6, which is 6. And all the distances in the Cartesian plane are in units. Okay. Similarly, if there is a point R in the fourth quadrant, let's say it is 4 comma minus 3, then what will be the distance of this perpendicular distance of this point R from the x-axis? It will be modulus of minus 3, not minus 3. Modulus of minus 3 means it is 3. Okay. So for this problem, the perpendicular distance of the point P from the x-axis will be the modulus of the ordinate of the point P, which is 3. So the correct choice is B. Let's see the next problem. The perpendicular distance of the point P, the same question, but it is now asking the perpendicular distance from y-axis. So the perpendicular distance of the point P from the y-axis will be the modulus of the abscissa or the x-coordinate, which is 4. So the correct choice is A. Let's see the next question, question number 5. The points other than origin whose abscissa and ordinates are equal lie in the, okay, whose abscissa and ordinates are equal. Now, what will be, so if all points whose abscissa and coordinates are equal will be of the form A comma A, where A is any real number. Where A is any real number. This is a set notation from the set theory. A belongs to R. R is the set of all real numbers. This means that A is a real number. So the form of the coordinate or the points whose abscissa and ordinates are same will be of the form A comma A. But in the problem, it has asked the points other than origin. So all the points whose abscissa and ordinates are same, but excluding the origin will be of the form A comma A, but A not equals to 0. Other than the origin, A is not equals to 0. So those points, if you join those points, they will form the graph of those points where the abscissa and ordinates are same, and those excluding the origin will form a line something like this. It will be a graph. This is the line. It will be the graph of all the points. If you ask what will be the graph of all the points whose abscissa and ordinates are same, but those points does not include the origin, it will be actually consist of two rays. This ray, now this point A, it is not touching the origin. It is not touching the origin. This point A is you can say it is very close to origin, but it is not the origin. And let's say AB. So this if you consider the straight line, if you consider the AB, if you join the point A and B, if you consider the AB as a straight line, then it will be the straight line y is equal to x. Since you see the form of all the points, the coordinates of all the points is A comma A. Abscissa and ordinate are same, which means y is equal to x will be the equation of all the points whose abscissa and ordinates are same. And this ray AB is the graph of all points, is graph of y equals to x, where we must have x is greater than 0. X is greater than 0. Now the question has asked the points other than origin whose abscissa and ordinates are equal, but so the line, the line or the graph of the equation y equals to x is basically a line. So it will be actually like this. It will also extend towards the below the x-axis and to the left hand side of the y-axis. So let's say this be C. So actually, so basically all the points, that the question is asking will be all the points that are lying on the line y equals to x, but x is not equals to 0. The points that the question is asking are the points lying on the graph y equals to x, where x is not equals to 0. So where will all those points lie, in which quadrant? So x is not equals to 0. If you consider x is greater than 0, then obviously all the coordinates, all the points lying on this is lying on the graph of this equation y equals to x, where x is greater than, where x is let's say greater than 0, will be on the first quadrant, and all the coordinates, all the points lying on the graph of y equals to x, where x is less than 0, will lie in the third quadrant. So all the points other than origin whose abscissa and ordinates are equal lie in the first and third quadrant. So choice C is the correct choice. Let's see the next problem. Question number 6. The points whose abscissa and ordinate have different signs will lie in. Okay. So let's see in which quadrants the sign of the abscissa and ordinates are different, that is of opposite sign. Okay. We know first quadrant, in the first quadrant, all points in the first quadrant, we know abscissa is greater than 0, abscissa, that is x coordinate, is greater than 0, and also the ordinate or y coordinate is greater than 0. In the second quadrant, we know that abscissa, since the second quadrant is towards the negative direction of x axis, x abscissa or x coordinates of all points in the second quadrant will be negative, x less than 0, and the y will be greater than 0, since the second quadrant is lying above the x axis, meaning it is in the positive direction of the y axis. So for the third quadrant, we see x will be less than 0, that is abscissa of all points in the third quadrant will be less than 0, and the ordinate of all points in the third quadrant will also be less than 0. And in the fourth quadrant, abscissa of all points in the fourth quadrant will be greater than 0, and ordinate of all points in the fourth quadrant will be less than 0. So now we can see in which quadrant the signs of x and y are opposite, this one and this one. So the second and fourth quadrant are the quadrants where the abscissa and ordinate of all the points are opposite sign. So second and fourth. So the correct choice is D. T is the correct choice. Let's see the next problem. If the perpendicular distance of a point P from the x-axis is 5 units and the foot of the perpendicular lies on the negative direction of the x-axis, then the point P has. Okay, so we have to find the coordinate of the point P. So what is given? The perpendicular distance of a point P from the x-axis is 5 units. Now this means that the ordinate, the perpendicular distance of a point from the x-axis means the ordinate. Now the ordinate could be negative or it could be positive. For a particular perpendicular distance, so let's say this is the x-axis, this is the y-axis, y, x dash, the origin, x, y dash. So the point P, it is at a perpendicular distance of 5 units from the x-axis. Now this perpendicular distance, it could be either above the x-axis or it could be below the x-axis. Okay. Also, if the perpendicular distance of a point P from the x-axis is 5 units and the foot of the perpendicular lies on the negative direction of x-axis, then the point P has. Okay. Now, it is given that if the foot of the perpendicular, that is, if you draw a perpendicular from the point P on the x-axis, that perpendicular where it will intersect the x-axis is the foot of the perpendicular. So that foot is in the negative direction of the x-axis, so it will be somewhere to the left hand side of the y-axis. So let's say this be the foot of the perpendicular Q. Now, so the point P could be either above the x-axis, it could be here, or it could also be over here. In both the cases, we will have, so for these, let's say so there are two possibilities of the point P. Let's say one is the P and other one is the P dash. So if the point P is below the x-axis, then also its distance, let's say if the point P is if we don't know the distance of the point P from the y-axis, that is not given. So we cannot say the abscissa or x coordinate of the point P or P dash or even Q. Let's say it be alpha, but we know that the point P is at a distance 5 units from the x-axis. Now, since point P is below the x-axis, the ordinate will be -5, and the coordinate of the point P dash, the other possibility of the point P, it will be alpha and 5. In both the cases, whether the point is P or P dash, we see the foot of the perpendicular will always be Q, and both the point P and P dash is at a distance 5 units from the x-axis. Now, so the choices are, then the point P has abscissa is equals to 5 only. Abscissa is 5. No, abscissa will not be. Abscissa is not 5. Abscissa can never be 5 because the distance of the point P is not known from the y-axis. Y coordinate is 5 only. Now, as we have discussed, there are two possibilities of the point P. It could be P or P dash. P dash in my diagram is alpha comma beta, and P is alpha comma minus 5. Because the point P is at below the x-axis and still at a distance of 5 units from the x-axis, and the point P dash is also at a distance of 5 units from the x-axis but above the x-axis. So there are two possibilities of the point P. That is, there are two possibilities of the ordinate or y coordinate of the point P. It can be either 5 or it can be -5. We cannot say anything about the abscissa of the point P because nothing is said about the distance of the point P from the y-axis. So the correct choice is D. The y coordinate could be 5 or -5. And the foot of the perpendicular lies on the negative direction of the x-axis. Okay. Okay, let's see the next problem. Question number 8. If the mirror image of the point P 5,2 in x-axis is the point Q and the image of Q in the y-axis is R, then the coordinates of R are. Okay. So let's draw the Cartesian axis y 0, y dash, 0 not O, x dash O, x. So the point P is 5, 2, somewhere here. Approximately, this is the point P on the Cartesian plane. Now, the mirror image of the point P in x-axis, what will be the mirror image of the point P in the x-axis? That is, how do we find the mirror image of the point graphically, geometrically? How do we find the mirror image of the point P in x-axis? You will draw a line perpendicular to the x-axis that will pass through the point P. They say this be the line. A line perpendicular to the x-axis that is passing through the point P. And this line, wherever it will, and this, okay. So, let's say, now the image of the point P will be along this line, and it will be below the x-axis. Since the point P is above the x-axis, the image of the point P will be below the x-axis and at the same distance as the point P is from the x-axis. The point P is at a distance 2. The point P is at a distance 2 from the x-axis. So its image will be below the x-axis and at a distance 2 from the x-axis, somewhere over here, P dash. Its abscissa will be same, but its ordinate will be negative of the ordinate of P, that is minus 2. Always remember, and now this is the geometrically how you find the image of a point P in y-axis. Now mathematically, if you have a point P, let's say if you have a point A whose coordinates are say alpha comma beta, that is abscissa is beta, abscissa is alpha and ordinate is beta, reflection or image in x-axis, what will be, let's say the point is B. B is the image of the point A in x-axis. It will be, the abscissa remains the same and the ordinate becomes negative, minus beta. Similarly, for the same point A, alpha beta, if you take image, what will be its image? What will be the coordinate of its image in y-axis? Y-axis, let's say it be B dash. You keep the ordinate same, and you take the negative of the abscissa, minus alpha. Okay. So if the mirror image of the point P, which is 5, 2 in x-axis, is the point Q, so this will be actually Q. This is given as Q. So the coordinate of Q is 5, minus 2. And the image of Q in y-axis, what will be the image of Q? How do we find the image of Q in the y-axis? I will draw a line perpendicular to the y-axis that will pass through the point Q. Let's say this be the line. And along this line, since the point Q is to the right hand side of the y-axis, I will take a point to the left hand side of the y-axis on the same line. Let's say this be AB, the line be AB, on the same line AB and at the same distance from the y-axis. The point Q is at a distance of 5 from the y-axis. Since the abscissa or x coordinate of point Q is 5, it is at a distance of 5 units from the y-axis. So its image will be to the left hand side of the y-axis at the same distance of 5 units. Let's say this be. So this is R. Its coordinates will be minus 5, minus 2. Because why minus 5? Because the point R is to the left hand side of the y-axis, means it is in the negative direction of x-axis, and the point Q was in the positive direction of the x-axis. Now this is how you draw geometrically, but mathematically, as I said, the concept is any point A, alpha, beta, its image in the x-axis will be, you keep the x coordinate same and take the negative of the y coordinate, so it becomes alpha, minus beta. Similarly, the image of the point A in the y-axis will be, you keep the ordinate same, there is a y coordinate same, but take the negative of the abscissa, so it becomes minus alpha, beta. Okay. So the coordinate of the point R should be minus 5, minus 2. So the correct choice is B. B is the correct choice. Let's see the next question. The distance of the point P 4 comma 3 from origin is. Now they always remember this formula that, let's say this is the Cartesian coordinates y o y dash x, any point in the Cartesian plane, if its coordinates are alpha comma beta, that is abscissa is alpha and beta is ordinate, what is this distance? That is the distance of this point O, of this point from the origin. This is the origin. So if you join the point origin, if you join the origin O and the point A, you will have the line segment OA. So we have to find, so the length of the line segment OA is the distance of the point A from the origin O. What will be its distance? When you are given the coordinates of the point A, you just drop, it is based on the Pythagoras theorem and the triangle, the right angle triangle. The formula is, you must remember this formula, that the distance of any point having coordinates alpha comma beta from the origin is square root of alpha square plus beta square. That is OA is equal to square root of alpha square per beta square. But remember, this value will always be positive. Let's say OA. Okay. So now for this point, for this problem, let's say this be the point P. One second. So we have the point P is 4 comma 3. Let's say this be the point P, 4 comma 3. So we have to find OP. So if you draw a perpendicular from the point P on the x-axis, so O and the foot of the perpendicular be Q. So the triangle OPQ is a right angle triangle, and you have OP square, that is hypotenuse square, is equal to OQ square plus PQ square. We have to find OP. The distance of the point P from the origin O is the line segment OP, or the side OP in the triangle, right triangle OPQ. OQ, what is OQ? OQ is the foot of the perpendicular from the point P on the x-axis. So its coordinates will obviously will be 4 comma 0. What is OQ? OQ is the distance of the point Q from the origin, and since the Q is lying on the x-axis, its distance will be equal to the modulus of the abscissa, which is 4. So this is 4 square. And what is PQ? PQ is the distance of the point P from the x-axis, which is equal to the modulus of the ordinate of the point P, which is 3 square. This is 25. Now OP square is 25, so OP will be equal to square root of 25, not plus minus square root of 25, but positive value of square root of 25, which is 5. So the correct choice is C. You must remember this formula, that for any point A having a coordinates alpha comma beta, that its distance from the origin O is square root of alpha square plus beta square. Let's see the last problem. The area of the triangle formed by the points A, B, C is, okay. So you must be very familiar in plotting points on the Cartesian plane. You should not make any mistake. Okay. Let's plot the points A, B, and C. A is 2 comma 0. 2 comma 0 will be a point lying on the x-axis, because the ordinate is 0. Y coordinate is 0 means that point will lie on the x-axis. So let's say this is A 2 comma 0, means the point A is at a distance of 2 units from the origin O. Let's see point B. Point B is 6 comma 0. Okay, so I have to draw the points correctly. Let's say this be A 2 comma 0. So the point B is 6 comma 0. Its ordinate is 0, which means it will also lie on the x-axis, and it will be at a distance of 6 units from the origin O, and 6, the abscissa is 6 positive, it will be, the point will be in the positive direction of the x-axis. So let's say this be point B, that is 6 comma 0, and the point C is 4 comma 6, meaning it is at a distance of 4 units from the y-axis in the positive direction of the x-axis. That is, both the abscissa and ordinate are positive, means it will be a point in the first quadrant. So the 4, it will be at a distance of 4 from the origin O in along the from the y-axis. So point A is at a distance 2 from the y-axis, point B is at a distance 6 from the y-axis. Definitely the point C will be at the distance of the point C from the y-axis will be equal to the is equal to 4, obviously, and if you, so C will be somewhere over here, 4 comma 6. Okay, so this is the triangle formed ABC. Now how will you find the now clearly we can find the area of this triangle if we know one side, if we know the side, one side, and if we know the length of the perpendicular drawn to that side from the opposite vertex. Okay, now you will notice that what will be, so if I draw a perpendicular from the vertex from the point C on the x-axis, let's say the foot of the perpendicular be D. What will be the length of CD? What will be, so the perpendicular, so then the area of the triangle will be half into AB into CD, where CD is perpendicular drawn from the vertex C on the opposite side AB. Do I know CD? Do I know AB? What will be AB? AB is the distance between the points A and B, and the points A and B are both lying in the x-axis. So how do we find the distance of 2 points which lie on the same axis? Same axis is lie on the you can say not on the same axis, but whose let's say whose either abscissa are same or ordinates are same. Let's say there are 2 points A. Now visually you can clearly understand that the distance or the length AB will be definitely equal to 6 minus 2. That is quite obvious geometrically from the graph. So this will be equal to the area of the triangle ABC will be AB. AB is the distance between, AB is the we can consider AB as the base of the triangle ABC. AB will be the distance between the point A and B on the lying on the x-axis. X coordinate of B is 6. X coordinate of point A is 2. So definitely the distance with AB will be x coordinate, since B is lying to the right hand side of the point A. The distance will be x coordinate of abscissa of B minus abscissa of A, which is 4, multiplied by what is CD. CD is a perpendicular drawn on the x-axis, where D is the foot of the perpendicular. So I can say the CD will be equal to the distance of the point C from the x-axis, which is equal to the modulus of the ordinate of the point C, which is 6. So this is equal to 12. The area of the triangle formed is 12 square units. So the correct choice is B. Now one concept I want to discuss is that how do you find in some special so the distance between 2 points. So let me discuss about how do you find the distance of between 2 points, considering some special cases. Let's say I have the Cartesian plane y o y dash x dash o x. So I have in general without any loss of generality, I am considering, I am plotting the 2 points A and B in the first quadrant only. A be the point, let's say A be the point x1 comma y1 and B some other point x2 y2 y2. So if you know the coordinates of 2 points A and B, what will be the distance between them? What will be the distance between them? That is, if you join the point 2 points A and B, AB, the line segment joining the 2 points A and B, it will be square root of a square of the difference of the abscissa of the 2 points. Square of the difference of the abscissa of 2 points. What is the difference of the abscissa of 2 points? You can consider x1 minus x2 or even x2 minus x1. It will not matter. I am considering x1 minus x2. This is the difference of the abscissa of the 2 points. Its square is this. Plus, similarly, the square of the difference of the ordinates of the 2 points. y1 minus y2 square. This is the formula to find the distance between the 2 points A and B, where the coordinate of point A is x1 comma y1 and the coordinates of the point B is x2 comma y2. This is the formula. Straight away, using this formula, you can find the distance between A and B. Now, in some particular cases, depending on the coordinates of the A and B, you can also quickly find, without using this formula, you can easily orally find the distance. Consider if the abscissa of the 2 points are same, meaning they will be at a same distance from the y-axis and they will be also of the same direction of the x-axis. 2 points having same abscissa or x-coordinate means they are at the same distance from the y-axis and they are in the same direction of the x-axis. Let's say those 2 points are P. Let's say the coordinates of the point P is alpha, comma, beta, and let's say other point Q, which is having the same abscissa, Q alpha, but a different ordinate. What will be the difference between the points P and Q? We don't know beta and we don't know the beta dash. It could be anything, but we know that the abscissa of the point P and Q are same. They are alpha. So what will be the distance between the point P and Q? PQ will be the modulus of the difference of the ordinate of the points P and Q, beta minus beta dash. Beta minus beta dash is the difference of the ordinate of the points P and Q. Their absolute value will be the distance between the points P and Q, where the points P and Q are having the same abscissa or the x coordinate. Similarly, if the ordinate of 2 points are same, what will be the distance between them? Let's say 2 points having same ordinate means they are at the same distance from the x-axis. Okay, so no, 2 points having same ordinate means they are at the same distance from the x-axis and they are in the same direction of the y-axis. I am considering, let's say, those 2 points are R. Let's say R be the point. Let's say alpha comma beta. Not alpha comma beta. I have to use some another variable or letter. Let's say this be u comma v, where u is the abscissa and v is the ordinate of the point R. Let's consider another point S. which will have the same ordinate as the point R, S, same ordinate V, and let's say this the abscissa of the point S is U dash. What will be the distance between the point R and S? If we join the points R and S, the line segment RS is the distance between the point R and S. What will be the distance? When we know that the ordinate of the points R and S are same, which is V, and their abscissa are U and U dash, RS will be equal to modulus of the difference of the abscissa of the points R and S, that is U minus U dash. So if two points have same ordinate, then the distance between them will be equal to the modulus of the difference of their abscissa, and if two points have the same abscissa, then the distance between them will be equal to the modulus of the difference of their ordinate. Okay, now so this concept and straight away a direct formula to find the distance between any two points given the coordinates as x1 comma y1 and x2 comma y2 will be equal to square root of the square of the difference of their abscissa, which is x1 minus x2 whole square, plus the square of the difference of their ordinate, that is y1 minus y2 whole square. This formula. I hope solving this problem will give you a good insight and idea of and concepts of how to apply the concepts of coordinate axis, the quadrants, the location of any point depending on the abscissa and ordinate, distance between two points, and the distance of any point from the origin, how to find the area of triangle or any plane figure which are formed by joining some given points. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will probably make a video where I will discuss about all the key concepts from the chapter of coordinate geometry. That is, I will briefly discuss the key formulas and the results and the concepts. It could be a little long, maybe it could be 1 hour, but it will be very, very important. So please stay tuned for that video. But before that video, I think I will solve another set of problems from this chapter of coordinate geometry. So thanks for watching, and until the next video, take care and bye.